Good morning. I want to share with you through this video all the information about the lab that we are going to have for this week. The lab is going to be a lab for 2 weeks. Okay, since we have another lab running now, this one will not be due until March. I believe it's gonna be 6th. Okay, then it's not gonna be the coming Sunday. No, it's like the one after. Let me check again. I'm not good in remembering the dates. Yeah, it's gonna be March 6th. Okay, it has 3 parts, and it's gonna be a formal lab report. And I'm gonna explain for you in details what you are going to do and show you some of the work that I did already. Now, we are going to verify the first law of thermodynamics. We are going to use it to understand the law and to calculate the work done, the heat, the changes in the internal energy of the system. We are going also to study relations between pressure and volume, between pressure and temperature, volume and temperature, and like so many things we are going to do in this lab. This is going to be a formal lab report, and since it is a formal lab report, you should stick with that. Okay, I'm sorry, like this is here. You should stick with, let me share with you my Word document about the lab, the format of the lab report. Here you are going to say Physics 203. This is going to be Lab 5, First Law of Thermodynamics, my name, my partner's name, the date. You're going to have the abstract, the equipment, the procedure. There is a part very similar to the ideal gas law where you are going to have a pre-lab. You are going to have it here. You are, for the data, everything done on Excel is going to be part 1, part 2, part 3. Remember also, beside your file, which is going to be the Word document, you should submit an Excel file. For the calculations also, you're going to say part 1, part 2, part 3. You're going to maybe say something about the volume, how the volume was calculated. Also, I'm asking you to calculate some of the quantities from the graphs. And it's going to be also here for the calculations. You should have part 1, part 2, part 3. The graphs, I'm asking you to do snips at the beginning of each section and a snip after. Like, you know, there are 2 snips for each part. Then I'm going to have the snips here, part 1, part 2, part 3. Also for graphs, I might have more than 1 graph for every part. Then you are going to copy paste your graphs here. You're going to have your results listed here and questions, answer all the questions. There is questions about like comparing your prediction with what you got actually. Then you're going to answer these questions, and any questions, you're going to find them in the handout. And finally, you should have a conclusion. Then this is like basically the format that we are going to deal with. Okay, let me get rid of this. Let me save that. Okay, then this is gonna be, I'm gonna save this as lab 5. First law of thermodynamics. Okay, I'm gonna have it in my Cerritos here and the labs. Okay, and then I'm gonna get rid of this here. This is my Excel file. I'm gonna show you now here on Canvas, where you're gonna get, of course, Lab 5, First Law of Thermodynamics. you have here's the instruction, the rubric, and the submission. Okay, now I have also my instructions open here. Okay, then it should be this one. All right. You are going to investigate the first law of thermodynamics. We are going to perform experiments to investigate relationships between work, heat, and internal energy of a system. We are going to determine the characteristics of different types of thermodynamic processes. We are going to study these, create graphs based on observations. And this is here my predictions, where you are going to say what's the shape of the PV graph for isobaric, isochoric, isothermal, and adiabatic, and you need to explain your reasoning here. Now, after that, we are going to go to the simulation where we are going to have the FET, and just here I want to read from my sheet after that, because I want to share with you my screen. Okay, then this is really here where we are going to access. Can you see this link in blue? You will be able to access the software. Okay, then I'm gonna go to my software. Okay, and there is a you're gonna click here on ideal. Okay, and this is what you are going to see. Now let me start from the beginning. Of course, I will not use my data here because I already did the experiment. I will share with you what is my actual data, but I want to show you how we are going to work with this experiment. The first objective is to investigate the relationship between volume and temperature. In addition, graph the relationship between pressure and volume for an isobaric process. Isobaric process means is gonna be constant pressure. Now, you are going to pump gas into the chamber here, and that amount is not gonna be changed throughout the experiment, because based on this, I will be able to determine what is really the number of moles, and therefore I don't want any changes in this. Then if I will decide I want to pump 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is going to be constant throughout the experiment. You will not add more gases, okay? More gas molecules. Now for the first part, under hold constant, check the pressure versus like that one here. This is the one that I'm looking for. And you are going to record the initial temperature here in kelvins. And then you are going to start the experiment from having the width. Okay, let's see here. The width here is going to be 5. The first value we are going to start from is 5. Now I'm going to assume that this is like a 3-dimensional container, where I have now the width is 5 nanometers, and I'm gonna get the length 12 nanometers and the height 5 nanometers. Then simply the volume can be calculated as length times width times height. Okay, and I can read actually the initial temperature. Okay, and okay, sorry, like did I say, okay, you're gonna read that temperature here. Okay, and start recording at width 5. You're going to take a snip of this. Then like the first snip is gonna be this one. You're going to have it into your lab reports. And I will say after that, okay, I will record here. I like in the pump, I'll record the initial temperature, start recording at width 5, take a snip, and change the width of the container, and we are going to record the temperature for every volume. Remember here, the pressure is going to be constant. Then you're going to record what is your pressure. For me here, it is 50.1 atmosphere. Of course, you're going to see that this is different from what I did previously, since I did with different number of molecules, different setting. I will change, then this is, I read the temperature, then I'm going to increase this to 6, and I'm going to read the temperature again. And then I'm going to change this into 7 and read the temperature. 8 and read the temperature. Okay, till you're going to have until 15. When you reach the 15 here, you're going to take another snip here. Then you are going to take another snip, and you're going to say the temperature is 450 K, and you're going to snip of that. You're going to record all this data under part 1 in your data section, and you are going to say isobaric process. The volume calculation will not be under the data section. It should be under the calculation section. Okay, now let me share with you part 1 graphs here. Okay, and data. Then here I'm going to go to my Excel sheet. And I will say, okay, let me see how I'm gonna see my data part 1. Okay, this is my data part 1 here. And this is my width, this is my pressure, this is my temperature in Kelvins, and this is my volume calculated. After that, I will graph pressure versus volume. Okay, this should be my first graph. Okay, I don't know why it's like it disappeared. Okay, and this is, and I will compare it with my predicted one. Of course, here your graph should have the correct, let's say, labels, units, and title. I will also graph volume versus temperature. Okay, then volume versus temperature. This is my graph. Again, it should be labeled. It should have a title. I did not put these. But the most important part here is you're going to right click and make that format trend line. Being sure that this is a linear, and you're going to display the equation on the chart because I need the slope. And I will share with you, the calculations in another recording. Now, I will use the first graph to calculate the work done during the process in joules. Now, just here, when we go to this pressure versus volume graph, this is the shape of the graph. You are going, remember, the area under the graph is going to be your calculation for the work done. But remember here, the pressure is an atmosphere. You need to change these units, and also the volume is in nanometers cube. You need also to change these units. And then you are going to calculate the work done. You're going to use this graph here again. Okay, the one that I was, okay, let's share it, trend line. Okay, I will use the slope here for the calculation. I will calculate N times R, not only N the number of moles, and then I'm gonna have the product of N times R because I will use it in the calculation of the change in internal energy. Okay, then you will do step 18, calculate the change in the internal energy of the system in joules. And then after I have calculated the work and the change in the internal energy, I will be able to calculate Q and say if the heat was actually absorbed by the system or expelled by the system. Then this is really part 1. Okay. Now for part 2, we are going to basically repeat the same thing, but as I said, we're going to keep the same amount of gas. And our second objective is to investigate the relationship between pressure and temperature. And here we are going to hold constant the volume. Then I will say the volume is going to stay constant. And okay, just before that, you can keep it at this number. You can put it at another number, whatever you're gonna do. If you wanna adjust that, nothing you will say, and then you are gonna adjust which volume you wanna have. Okay, constant throughout the experiment. And then now you are going to take a snip. Okay. No, I said like for the initial, sorry, for the isochoric, I asked you for a certain value. Then you're gonna keep it at 5 initially, and then you're gonna make it constant, and then you are going to take the snip and insert this under the graph section. Now, after that, you are going to start. Here, I say, I want you to start first from 100. Okay, then can you see how I am lowering the temperature? I want to start here from 100. Now I will read the pressure value for this temperature. I want you to, when I want you to look at the like the pressure here, you're gonna see that the pressure is really fluctuating, but it's not fluctuating much, which means I will say take any value. Okay, for example, like 33.6, whatever value. Okay, it's not going to be that affecting your data that much. And it's going to be for part 2 and part 3 is going to be the same. Because this is like based on, like the collisions between, because remember, the pressure is based on the collisions, then it's like it's going to be fluctuating a little bit. You are going to take, as I said, a snip of that, and then you are going to actually start changing the temperature. Okay, then I want to raise the temperature by 10 Ks only. Then I'm going to say, okay, this is 110. All right, and then I'm gonna read the pressure, and then I will again go to 120, 130, 140. Every time you are going to record the pressure, and that is gonna be the data under section called data part 2 isochoric process. And under the calculation section, you are going to have another section called part 2 isochoric process. You are going to have the table for your calculation of the volume and the other calculations that I'm gonna ask you for. Now, when I did part 2, okay, then this is my, where is my data? Part 2. Where is my data? Like I lost my data. Yes, that's part 2. Okay, then this is my data for part 2. Look here at my volume is going to stay the same, and I have the temperature and the pressure values. You are going to graph pressure versus volume and compare it with your predicted one. And then also you are going to calculate the work done during that process and calculate the change in the internal energy of the system in joules. Now, since we have the same number of moles, you can use the same R times n, the one that we got from part 1. You don't have to recalculate that, okay? And that is going to be, we can use it again so that we will be able to calculate the change in the internal energy of the system, and then also calculate the heat and indicate if it was added or removed from the system. Okay, for part 3 also, okay, I will have the same amount of gas, and let me go again. In this one, I'm gonna have the temperature constant, and I will start also the volume from 5 till 15. Every time I'm gonna read the pressure, and I'm gonna have under data section a new section said part 3 isothermal process, where I'm gonna list my data. I'm gonna have under the calculation section again part 3 isothermal process. I'm gonna have my calculation for the volume, and also you know, any calculation that I was asking you to do in you know, steps that they are really listed under the instructions. Now here I want maybe to share with you also my part 3. Here is my part 3, and with my part 3 I will say, when you are going to have the pressure versus volume, is not going to be a straight line. That fit should be power, because here I have the pressure and the volume. It's going to be P equal a constant times 1 over V. Then, and this is Y is going to be like something like this, okay? You're going also here to calculate the work done, and I want to bring to your attention that here I don't have a rectangular shape. Then what I will do is, like, this is the reason why I did choose this design for my graph, so that I will have this is area can be calculated easily. You have here a rectangular shape, and here you can approximate this to a triangle. Then you are going to say the area under the curve is equal the work done, and that is going to be the area of the rectangle plus the area of the triangle. Calculate that. Remember always that my pressure is in atmospheres and my volume is in cubic nanometers, and they should be converted. All right. This is what I want to share with you here, and of course you are going to calculate the change in the internal energy of the system as well, and also talk about the Q, which is the amount of heat. Now the last table here, the last step is gonna be there is 17 where I'm gonna list the table that is gonna be this one should be under your results section. For the adiabatic, we did not do any work, but you can comment on, when I have adiabatic, what quantity is going to be 0, and maybe what is the relation between the other two equations. And also from the part where we calculated the this in the lecture, you're going to give us the work equation that we did study. Okay, we did derive. All right. I will also show you using my iPad another short. I will share with you another really short video where I'm gonna explain to you the calculations for this lab. Thank you very much. See you soon.